Inspired by a flower, since many schools can't plant flowers due to the risk of bee allergies, this subsystem sits in a garden bed and uses a particle photon to record environmental data, including soil moisture, light, temperature and humidity, sending all of this to a cloud at preset intervals over Wi-Fi. Sensors were chosen due to their ready-to-deploy or easy-to-deploy capabilities. Complicated wiring is avoided so that kids can be involved in as many steps as possible, building a sense of ownership for this object. The leaves act as a locking mechanism to hide or reveal the electronic internals. The design avoids pins and gluing to make it as safe as possible for students to use. This prototype has been made out of 3D printed plastic. It is being painted to show what it should look like, however the intention is to have each component printed in its intended colour to improve the sustainability of the end-of-life processes. Pins have been designed throughout the flower to secure components in designated sections. Unfortunately, not all aligned for this iteration. These holes are designed to guide wires between the layers, further simplifying the build process. The petals are purposely angled to direct water away from the main components located in the stem. Future designs would include a vacuum-formed clear acrylic cover which would protect the light sensor and solar panel from the weather without inhibiting functionality. The form of a ladybug was chosen to match the value criteria for promoting diversity while highlighting how ladybugs help look after the garden. It also has a pleasing organic shape that is nice and bright to draw attention to itself in the classroom. The ladybug has a paired particle photon so it can read the data from the flower. It is then powered by a battery and/or wall adapter. The 5 faces are representations of the health of the garden. The graphical element is intentional in assisting with the development of students' emotional intelligence, as well as catering to varying learning levels. Determining which face is displayed depends on the plant chosen for growing. This will be explained later in the Learning Hub section. Using rapid prototyping tools, this mock website can demonstrate the user flows intended for the Learning Hub. The sign-up process is designed to guide you through step-by-step on how to set up your profile based on your user type. For example, students will be shown LEGO-inspired instructions in order to set up the previous subsystems for use. Students are given a set menu of options by the Garden Manager from which they can choose to plant. The Garden Manager sets up the plant profile through their user stream, which is what sets the operating range of the sensors. The main sensor page for all users looks like this, with some user-specific differences in the left-hand panel. A wide user group is catered for through simple emotive, colour and language communication of data. The data can be seen over time through a deep dive view, carrying across the colour ratings for consistency. Other functionalities include recording activities to foster ownership and knowledge building. Students and teachers suggested the ability to add images to enhance engagement and demonstrate active participation. You may also refresh sensor statuses, link to weather services, investigate historic data, and engage in digital learning opportunities. Importantly, the Ask for Help functionality primarily links you to your wider school gardening community to negate drops in participation from a lack of knowledge and hence builds self-efficacy. You may participate in this knowledge sharing journey through the Answer Questions tab. If we now look from a teacher's perspective, the main difference is the green tab, the Teacher's Lounge. Here they have the added functionalities to assist in classroom activities, including a link where lesson plans are available for maths, science, humanities, critical thinking and digital technologies. Garden managers maintain more of a bird's eye view of the system, being able to control plant options as well as view all sensors deployed throughout the school. Lastly, the settings page provides overall control of the size and maintenance of the system.